what are the careers for mechanical engineers, right? I think it's one of the very important topics for any mechanical engineer to understand what he or she fits, or what is his or her strength in the industry, right? I think starting with the research and development, yeah, the mechanical engineer would work on innovation topics. Innovation is key for any organization for that matter, right? Innovation is not only for the present, but it is also to safeguard your future business. Yeah, it's also very normal these days to see chief innovation officers in companies. Yeah, in the past we used to talk only about CIO, chief information officer, or CTO, chief technology officer, or CEO, chief executive officers, right? Now it's also pretty common to see chief innovation officers in a lot of organizations, mainly because they want to foolproof their future business. So they work on the cutting edge technologies. Yeah. So when you talk about innovation, yeah, if you are a R&D professional, or if you're a mechanical engineer working on innovation topic, yeah, you would also come across intellectual property rights, right? So IP is very important to again foolproof your company, so that the design whatever you do, yeah, it's not being replicated or copied by others outside your organization. So basically you get the rights for manufacturing or to work on your idea, right? So mechanical engineers create a lot of innovative solutions, and they also file a lot of patents, right? So as a mechanical engineer, even you would come across a lot of uh, phase in your career where you will be writing invention reports or filing the patents, right? So that's very important. And how this innovation happens, it's mainly because of the requirement or the market push for that matter, right? You talk about design. If you are a mechanical engineer working in R&D, yeah, certainly with respect to design, you'd work on a lot of conceptual design, you'd be working on a lot of developmental design, right? So here the objective of you would be to convert the customer requirements into technical requirements, and technical requirements to conceptual design, to conceptual design to a development design. So conceptual design, you could assume something like a top layer of design, and development design is something which can be made into a prototype. So you add a lot of information in a development design. So conceptual design can just be a rough sketch for that matter, but development design could be engineering drawings or computer aided design, see it CAD drawings for that matter, right? Reverse engineering, yeah, I think this is very important in the modern day. It's not mandatory that you would know everything as a company. Maybe you would also like to understand how your competitors are making the products, right? So on that context, what you would also do is you would, work on a product or a system, break it down into components and try to understand the functionality of each components. So that's what the reverse engineering is all about. Coming to the testing, in the testing you would be predominantly working on proving the functional requirements or safety requirements, whatever the objective of the product it is. Yeah, so you'd be making sure the objective of the product is met. So that's what you would be working on the testing side. Simulation. Simulation, basically you can also either put it above testing in the life cycle, or it could also happen concurrently along with the physical testing, right? So simulation is very important, mainly because you test the product virtually. Yeah, so when you're working in a virtual environment, you are doing something in a faster time, and you are also saving a lot of cost, right? Of course you have to have certain simulation infrastructure which should be one time investment, right? So through simulations You validate the design, whether it is meeting the objective or not under certain boundary conditions, right? So boundary conditions are very important for simulation. Yeah, you can't simulate each and every aspect of the product in its real life working environment. It's very difficult because the model complexity is going to increase, yeah, and your model accuracy is also going to increase. For example, to increase the model accuracy, your complexity increases much higher fold. So you need to have a trade-off between your model accuracy and your model complexity. Yeah, so that's important. So as a simulation engineer, you would predominantly work on understanding the physics of the problem. Yeah, if something has to be moved from point A to point B, as a simulation engineer, yeah, say for example, if you're working on the robot technology, yeah, you would try to understand the kinematics of it. You try to understand what is the load of it, how do I lift certain things from one position to another position, what is the shortest path to reach point B, and what is the amount of energy what I spend to reach from point A to point B, and whole lot of engineering. Yeah, so it's pretty exciting area in the simulation, that you will also come across a lot of engineering physics there. Coming to the prototyping, I would say the key objective of engineer in a prototyping team would be to develop the prototype what you get from the design team. Yeah, so here the volumes are not high, the volumes are pretty much lesser, just to make sure you do a testing, yeah, or show it to the customer, whatever it is. Data science, you also have a lot of mechanical engineers working on data science exactly in the data. Yeah, there is also, this is also applicable to the simulation, right? Garbage in is garbage out. Yeah, so for a simulation team, if you don't understand what's going in, you wouldn't understand what's coming out. Yeah, it is also applicable to the data. Yeah, it's important that you understand what type of data it is, and does the data make sense. Yeah, so it's very important as an engineer to understand and not blindly believe the data, right? So understand the pattern of the data. You also understand if the data makes sense, right? So data science also uh, is an area where the engineer actually thinks if the data makes sense, right? It's very important. Yeah, materials development. So mechanical engineers working in the materials development team to make sure, you know, he or she can create materials which are having super characteristic traits. For example, higher strength, much more higher durability, lesser cost, so on and so forth, right? So there are a lot of material science engineers doing a lot of research and development to make sure the materials objective or the materials requirement for the product is taken care. Coming to manufacturing, right? I think this is certainly, the scope is also much bigger. Yeah, the main objective for a manufacturing setup or for a manufacturing engineer would be to successfully take the design and create the products or components in a mass scale. Yeah, from a small pilot scale or a small prototyping level, you get the products into a series production. Yeah, where you talk about thousands and lakhs of components per day, whatever according to the requirements, right? So production is key there. So if you are a production engineer, you'd also be focusing on how we can improve the production or how we can improve the quantity. Yeah, so I mean, typically production industries or, you know, facilities works in shifts. You also come across a lot of industry which has shifts throughout the day, right? So mainly these teams will be focusing on meeting the organizational targets, in terms of the product quantity. Yeah. So they would basically work with machines, and you'll also have a lot of automation there, right? You will also have a lot of scope to increase the production. Say, for example, you could automate certain things, yeah, and come across, the objective of increasing the production. Yeah. Of course, if you are in the testing team, you would also test the uh, products, whatever it's produced, yeah, whether it is meeting the objective or whether it is meeting the certain quality or not. Yeah. So here, as a tester or as a testing team, yeah, the engineer um, would be focusing on creating cost effective testing procedure and high accurate testing procedures. Yeah, certainly it's not possible to test each and every sample whatever is being produced. So you need to also know a bit of statistics. You need to also know a bit of sampling procedures in terms of how you can take a sample out of population and test it and still represent the entire population, right? Coming to the quality, if you are a quality engineer, right, this mechanical engineer would focus on improving the quality of the product. Yeah, he or she will also lay down certain rules and procedures to achieve the quality. So here, one very important parameter which you also come across if you're in a plant setup is the parts per defects, or sorry, the defects per set of volume manufactured, right? So we also come across certain targets like 1 ppm or 2 ppm, so parts per million defects. So say for example, if it is 1 ppm, it's 1 parts per million defects which is manufactured, right? So this quality team is very important because it determines or it is directly linked to the customer satisfaction. Yeah. So coming to the sales and services, yeah, mechanical engineer certainly has a lot of thing to do in terms of sales and services, because at the end of the day, mechanical engineers understand the system, yeah, understand the way it is manufactured, yeah, and understand the physics behind it. If you are into sales and service, you could also work on technical project management, wherein you would amalgamate the entire value stream starting from the customer requirements till the product is delivered. Yeah, you would work on the entire stream or the entire chain. Yeah, and the success of a project predominantly lies on the technical project management, or you would also be called as technical project manager for that matter. Application engineering, yeah, so application engineers would also work closely with the sales team and the customer team and the engineering team. So they basically take the product, yeah, and work on the application of this product on the end environment or on the customer application. Yeah. And again, service engineering is also very important in terms of the customer satisfaction. Yeah. So if you are a mechanical engineering professional working in the service industry, or in the service engineering team, you would predominantly focus on delivering solutions to the customer, yeah, after the product is delivered, so or during the customer usage basically. Yeah. Procurement, of course, this is also closely linked to the manufacturing. Certainly you can also bring it under manufacturing, or you could also keep in silos, but certainly if you are a mechanical engineer working in the procurement team, you would focus on how you can uh, create a product, or how you can uh, purchase a product in a cost effective way. Yeah, so you basically do not rely on one particular vendor just to avoid monopoly. Yeah, so you would also have multiple options. Say for example, you may have some 4 to 5 vendors and you may choose the best among them, and you can also swap your purchasing capacity among these vendors to make sure you don't to make sure that you mitigate the risk, right? Operations. So you also see the right time when you can bring the product or when you can bring the raw material for the manufacturing. You also work a lot on operations, and you also work a lot on marketing, yeah, to make sure you get the right raw materials, yeah, at the right time. Coming to the product or domain opportunities for mechanical engineers, yeah, the application is pretty vast. Yeah, let's take an example of computing, data, and digital technology. Yeah, we also have the uh, computers, data centers, or any digital technology for that matter, where the mechanical engineers plays a major role. Yeah, health and medicine. Yeah, as I mentioned in the past, mechanical engineers works on diagnostics, uh, equipments building, or uh, building robotic surgical equipments, yeah, or building or creating wearable healthcare gadgets. For example, now we have the healthcare or wearable healthcare, which is gadgets which is pretty much common these days, right? So uh, you track your heartbeat or your pulse rate dynamically throughout the day. Yeah, and it has also in one sense improved the life of people, right? Coming to robotics and manufacturing, yeah, so say for example, you have a lot of uh, automated factories, or we also call it as dark factories, where the entire manufacturing happens in the dark, or without any human intervention, right? And you have a lot of robots, and I think for the past, at least over the last 1 or 2 decades, yeah, the robots usage in manufacturing had taken place, right? So you also come across a lot of avenues where human intervention is less and the process is automated with robotics, right, or robots. So for example, previously the operations which were pretty much posing a danger to the operator or to the human, right? Now these topics or these processes are automated with robots. Yeah? Air and space. Of course, this particular field has grown a leap over past decades. In terms of air, engineers are working on improving the safety of air travel as well as improving the efficiency. Yeah, now people are focusing on improving the fuel economy of an aircraft, how you can build uh, a light aircraft, right? And this also needs a lot of research on materials, a lot of new concepts, as well as a lot of whole new testing procedures, right? Of course, on the space side, yeah, you are also looking at uh, unmanned vehicles in space, right? Wherein you have to develop a product for an environment which you are not very sure about, right? I think this is also a sector where mechanical engineers adds a lot of value. Coming to the environment, sustainability, and energy. In terms of environment, mechanical engineers are also focusing on um, improving the life of the people, yeah, through green solutions. Yeah, so if you see, a lot of countries are now also having uh, emission targets, right? So the products or the solution, whatever mechanical engineers are thinking, Yeah, it's also becoming more and more environment friendly. uh, Engineers are thinking if the products is inflicting any damage to the environment. Yeah, if yes, how we can nullify it. Yeah, you also have a lot of industry or a lot of factories which says they are carbon neutral. It's not very common in the past to hear any factory or any organization telling that we are carbon neutral, right? And in terms of energies, yeah, people are harvesting the renewable energies. Yeah, I think over the last 2 decades, you also have a lot of solar energies, a lot of solar panels. It's very normal to come across solar panels these days. Yeah, and also a lot of windmills. Yeah, other than nuclear, yeah, we also have a lot of solar and windmills. Yeah, so these are also an avenue where engineers are working on improving the efficiency of the energy extraction process. Yeah, infrastructure, transportation, and society. Infrastructure, I think I don't need to say anything about infrastructure, mainly because you can physically see the infrastructure development, right? It could be in terms of technology, or it could be in terms of buildings, it could be in terms of vehicles, so on and so forth. Yeah, coming to the mobility solutions or coming to transportation, I think we also see a rapid leap in terms of development in transportation. Yeah, now we are talking about electric vehicles, now we are talking about autonomous vehicles, and now you are talking about even the internal combustion engine with very little emissions. Yeah, and also you also talk about smart cities. Yeah, so there are a lot of opportunities for mechanical engineers.